All right, so here we are. This is CNIT 128, and I didn't calculate the midterm grades yet. I'll probably get them up this weekend. But anyway, we're down to the third part of Android implementation issues, and I got the Frida project working. The one I've been saying didn't seem to work very well. Well, now it seems to work pretty well. So let's see, there's a comment there. Let's see. I missed public by default buckets. Yes. Yeah, well, we got public by default buckets again. All right, so let's take a look at the Android implementation issues, and then I'll demonstrate the Frida project, which is working very well. So here we are. And again, as I mentioned, we'll mention Drozer quite a bit in this lecture because it's mentioned in your textbook and such, but we're not using Drozer anymore. It seems kind of out of date, but it applies to any malicious app. You could make an app that could do these things. And I see another comment there. Let me see what it is. M305. It is M513. I'm not sure about M305. M513 works anyway. All right. All right. So we're down to part 3, talking about injecting exploits for JavaScript interfaces and sneaking data in. So to exploit your device with JavaScript interfaces, this is a combination of situations that used to be quite common among apps and may still be one. Probably the older apps would have this exact problem. Loading content over HTTP instead of HTTPS, running on an old Android SDK, then a machine-in-the-middle attacker can inject JavaScript code. You download something and you can just add code to it since it's not encrypted, and then you can just have a code injection vulnerability. You're injecting code, and therefore you turn the app into a bot and you can use it to mount further attacks. And this would effectively be able to do the attacks we're about to talk about that we attribute to Drozer. Just like now that app that's vulnerable would be your gateway in to exploit other apps on the phone. So you can attack Sony Xperia. Sony Xperia had an app that loads added over HTTP. So you could use Drozer and Burp to inject code that would then launch the Drozer app on the phone. And you could inject an agent. That would just be a way to demonstrate that you have the ability to create a request on the phone that goes to a different app. Right, so, and some apps you mentioned before manage their own update instead of relying on Google Play. Therefore, they have to have the install packages permission, and a bunch of them at one time, hopefully not anymore, although maybe, would download it unencrypted. And therefore, you could just have a machine in the middle that modifies the app so they get a poisoned app. That's APK replacement, and there are various tools to do that. This is another thing that would happen if people infect your router with malware, which is now getting quite common. The Americans have been doing it for years. The Russians dumped out our exploits from the NSA, and now Volt Typhoon is doing that. The attack that there's another bulletin went out today from CISA warning critical infrastructure operators in America of the Volt Typhoon Chinese group, and they are taking over people's routers. And if you take over your router, then you have a machine in the middle, then you can modify traffic as it passes through, unless it's protected by HTTPS. So you can invoke this, if you have installed the Drozer agent as a proof of concept, you can use these pwn schemas to activate it. And here's a cute one. This has happened many times, that a security product turns out to open a big security hole. There was an antivirus product that you put on the Mac about 8 years ago, and it would just open your machine to remote code injection. It had a listening port that would just run anything. And here's another example. Samsung had a mobile device management client, and it had an intent filter here that was browsable, so it takes requests from the outside, and the scheme just has to be SMDM. And so you could just send it an SMDM URI and install anything you want from your server, and it would install on the machine. Because this was, their client had, of course, the ability for your management to put an app on the phone, and they implemented it in an insecure way. This keeps happening to security products. There are a lot of antivirus products that have had a service running that would delete files, and you could just get it to delete other files and so on. This is a fairly common flaw. So it would just pop up a box like this saying a new version of the MDM client is available, and the user will, of course, click OK, but this could be anything. It wouldn't really be an update of the MDM client. So there's various kinds of malware. You can improve this with social engineering, or you can use a zero permission app to install additional packages. So drive-by downloads, this has been a problem for a long time. where there are pages that automatically install things. There's a problem on Safari a few years ago. So you have some kind of message pop up telling you missing plugin, app update required, something like that, and you trick them into installing malware. This used to be very common on sites that played videos. So you're missing a codec, so you trick people into installing malware. Now, in Android 7 and earlier, you would only be able to do this if you turned on unknown sources. Otherwise, it will only let you install from Google Play. So that would provide some defense. Now it's configured on a per app basis now, whether you require sources, which is sort of like the way a desktop Mac is. When you first buy a new Mac, you can't install anything until you go turn off this security feature, which lets you only install things from the store and nowhere else, the way iPhones do. And that is, of course, more secure, but it means you can't install anything except what's in the store, and most people are not content with that. And Androids do something similar. There also used to be a permission that would automatically launch every time you boot the phone, which is handy, but of course it's very handy for malware. So this has been restricted now. This used to be the plan. You received boot completed, but they turned that off all the way back in Android 3.1 because that's really dangerous. Although Windows has about 28 of them. They're called auto start extensibility points, and you can see them with auto runs. There are 4 registry run keys that do it, and there are many, many other ways to make something automatically launch when you boot up your Windows machine. But it's not that easy to do on Android anymore. So now, newly installed apps won't receive this intent, which is the message that says they've finished booting. And so this method is less common. What's more common is to have some kind of web page with an iframe in it that will launch the app, and then you just have to somehow trick them into going to that web page. But that's not exactly as good as making it automatically launch when you reboot the phone, which is sort of the ideal persistence mechanism. So Android 4, Chrome will no longer download an APK automatically on a page. You have to trick them into doing something. Can't launch it in an iframe. You have to trick the user into clicking to request it, but that's not that hard. You have an example like this where it shows you a plugin is required to display this content. Click on there to load the plugin, and what you're really doing is downloading an APK. Same old kind of trick. Social engineering is required. Now, there's another one. Some apps request no permissions. I've seen these. The app just contains static content, like pages of a textbook or something. It doesn't need any permissions at all, which is fine. However, there are ways to bypass the permission model. There are vulnerabilities you can use to install more permissions. There have been quite a few of these that have come out, and that's called breaking out of the sandbox. One way to do it is with a kernel exploit to escalate to root. There have been other vulnerabilities in various versions of Android that let you gain permissions that you're not supposed to have. And so there's also a command injection here. There was an app that constructed a command line doing this: dump state data log, and then it would take data from the user for the name of the log file. And this is a classic command injection vulnerability. In here, you can inject something like here with //dev null semicolon ID going on the SD card. This is just a proof of context exploit. The semicolon is the effective ingredient. If you put a semicolon here, it'll execute this command and then the next command. And here they just take your user identity and write it into a file on the SD card, which is one way to make a mark to show that you have control of the box. So this is the fundamental, most common flaw when you take user input and include it in a command. Then you're asking for this, unless you very carefully limit what input the user can put in. And here's something called object input stream, which is pretty cool. You could escalate privileges before Android 5 in this, and this was found by Rainforest Puppy, Jeff Forrestal, who is also the guy that discovered SQL injection. He's pretty hot and pretty important hacker in the world. And here's how it works. Android didn't check to see that certificates were signed by their issuer. By the way, the same thing was true of Internet Explorer version 3 around that time. It would just take a certificate and let me bring this up to make this clear. If I go to a page that's signed like mine, and I go to connection is secure, certificate is valid, well, I'm hoping I can see the certificate. I may not be able to figure out how to view the certificate in Opera. Certificate is valid. There, here's the certificate. So my website is signed by a certificate, and this certificate comes from Let's Encrypt. Now, if you go to details, here's the root of trust. samsclass.info is signed by someone called E1, and they're signed by someone called ISRG root X2. So to verify the certificate, first you start with the web page and say, does the name on the certificate match the name of the web page? Is the date valid? Okay, if that's fine, then it goes to see, well, who signed this? Do I trust this people? Well, I don't. They're not in the trusted store. So are they signed by somebody? Yes, they're signed by these people. So you verify this. You have to walk up the tree. And both Android and early versions of Internet Explorer just didn't bother to walk up the tree. They just looked at this certificate and believed it. You didn't really have to have a path of signatures going back to the root. And that means you could claim to be from any issuer. It just looked at the name of the certificate that issued it and didn't verify it. So you could just claim to be from Adobe, and then you get system privileges. That it didn't bother to verify it. So, they fixed that later, but this is the kind of thing that keeps happening. And these kind of vulnerabilities last for a while because the app works. You can go to normal web pages and download things. The user doesn't see a problem. So it can persist for a while, just like all the apps I've talked about that don't validate certificates. Users can use the apps. Nobody's complaining. It's not obvious to anybody that there's a problem. All right. And so to get data in, things you might do to analyze. Drozer has modules, and malware can do this. Banking malware stuff, record the microphone, read and send SMS is very popular for banking malware to get your second factor for two-factor authentication. Read your contents, capture your location, screenshot or video record screen. And this is what spyware does, like Predator, which you get from Israel. And it's used all over the place. By the way, the U.S. government and a whole bunch of other governments just issued an international agreement to try to fight that kind of spyware, which is used by oppressive governments all over the world. But it's out there. You can buy it, and people are using it like crazy. You could also disable SE Linux enforcement. SE Linux is security-enhanced Linux that adds a bunch of controls inside Linux. And you can set your Android to either have this feature or not to have this feature. If you have unlock patterns, I don't know if modern versions of Android do this, but there were versions of Android where instead of typing in a pin, you would trace out a shape on these things. And to get that, you'd record video. We'd want use of video to find that shape. All right. On earlier versions, the SD card was shared storage for every app, just like a public floppy, and that turned out to be a big problem. A lot of people put apps and put private data on there and expose it. Now you need a permission to access the SD card, so that's a little bit better than every app having permission, but it still is a shared location, shared by many apps. And you can get the Wi-Fi keys. The Wi-Fi keys are just stored in this file. wpa-supplicant.conf just has the passwords for your keys. It's pretty easy to steal them from the Windows or Mac OS machines too. Gmail accounts are stored in a SQLite database. However, they are not passwords, it's tokens. And I'm not entirely sure what good this token is. I think this token is a cookie that will get you into one session of Gmail, but it's not as bad as leaking out your password directly. But that data is stored on the phone and not necessarily stored very well. There is an Android secure storage API, like the Android, like the OS 10 keychain, but people just don't use it. They put insecure stuff in foolish places, security thing. And then there is, let's see, I think I see a comment in the chat. If that's why McDonald's went down internationally, well, I don't know. I saw McDonald's down, but I don't know why. Anyway, all right. So third-party apps might store plain text passwords, and they certainly do frequently. All right. And so you can find the gesture information here, and the passwords here, and there are public scripts to decode the way they're stored. So if you can get to these files, you can find out how they're logging in. And of course, the clipboard is a big problem. The whole point of the clipboard is to copy data from one app and put it in another. I was, in fact, just writing a risk assessment report last night for one of my clients where they asked how dangerous is it to let people bring their own phone to log in. And this is there's official National Institute of Standard guidance for this, which is what I based it on, that says one of the vulnerabilities is if they have their own home phone and they have company apps on it, now it's easy to copy data from the company app into other apps. Whereas if you had to have a separate phone, that would be harder. So that's one moderate level risk. Anyway, so there's a clipboard that stores a lot of data on it, and you can see it on Samsung devices. It's not in these emulators, though, so you can't do it in the projects here. And that's how most password managers work. They copy the password and put it in the app so they're in the clipboard. And the clipboard is, of course, shared by every app. So you could argue that's not a very good way to do it, but that is how they work. But you can, by the way, you can use the input command to send keyboard presses with ADB shell, which is kind of fun. And so you can do this to find the screen dimensions. How big is the screen? 1536 by 1952 of the phone, and then you can figure out how to click on one of these apps. So you can launch a particular app by figuring out the mathematical coordinates and then tap at that number. So you can, with command line control of ADB, you can do gestures and taps on the phone. All right, and you can extract application data. If you have physical access, you can just back up everything. This will get all the user and app data from everything, and you create a backup file. So it's one way to get all the data off the phone. All right, so let's take a look at the Cahoots. I've got them someplace. Here they are. This is 128.8c. All right, there we go. Yeah, and I saw the comment that people are having trouble using the that automated vulnerability scanner with the Drozer modules. I had the same problem. The only thing that worked was to get the screen images. All the other Drozer modules did not work when I tried it. And we'll talk about that, why that happened when we get to the projects. Seconds, people are still coming in. So, all right. So what content is it safe for HTTP? Nothing. If you load anything over HTTP, an attacker can add code to it, can change anything. So that's why using HTTP at all is now considered unsafe, and that's why almost nobody uses it. Almost every website is HTTPS.
Is this only for web page?
Yes, yeah. The HTTP web pages are nearly extinct because they're never safe to use. Yeah. All right. All right. So which method lets you escalate privileges in Android 4.4? Object input stream, which, by the way, is a deserialization vulnerability. There have been a ton of these, where you have data, and you combine it into a block of data with Java serial objects or other serialization, and then it has to be unpacked at the other end. And that has the effect I was talking about earlier, where the data that comes in is going to be expanded and reused once it gets in, so it often passes beyond the filter that's looking for bad things and then is unpacked later. This turns out the deserialization vulnerabilities are very common. You can sneak something bad in by serializing it so it doesn't appear until a later stage after the filter. So the object input stream had that kind of vulnerability. All right, so which file might contain passwords from email clients? Accounts.db is the system file where such things can be stored. I see them frequently stored just in arbitrary database files in the home directory of apps, but email is a special thing integrated with the system. All right, so what utility lets you simulate user screen taps? Yep, that's input. All right. Good name. I'll have to tell them who they are if they want the punch. Anyway, let me stop the recording.